Our next presenter for the day is Remy Fortin, a Ph.D. candidate under the supervision of Professor Salmaan in School of Architecture, and he will be presenting on cool running on the future of natural air conditioning and ventilation.
Global warming means we need more air conditioning to stay comfortable inside building and cope with dangerous heat waves. Oops. Mechanical air conditioners, like the one you see here, offer a simple fix. Unfortunately, they are also energy and carbon intensive. Their widespread adoption creates a dangerous loop because while they cool down our building, they contribute to global warming. In my PhD project, I'm tackling this issue by developing a new kind of self-cooling architecture that can stay cool and comfortable without mechanical equipment. I'm doing so by combining three key components. First, I'm using daytime radiative cooling material that can dissipate heat even under direct sunlight. They do that with selective spectral property that allow them to emit thermal radiation towards the sky, more thermal radiation toward the sky than they absorb coming from the sun. I'm combining those with enough thermal mass inside the building to stabilize its temperature against the natural fluctuation of the environment. And I'm designing ventilation opening that use the temperature difference between the interior and the exterior of the building to produce natural ventilation. Last year, I tested this combination in a field experiment in California. I used two plastic coolers. One had thermal mass and natural ventilation, and the other was identical except that the roof was a daytime radiator. Here are the results. In black is the exterior temperature, in yellow is the control, and in green is my prototype. It shows that with radiative cooling, my prototype could remain much cooler than its counterpart and even cooler than the average ambient temperature during sustained period. While this experiment was successful as a proof of concept, its main issue was that it used unsustainable material. Therefore, I'm now collaborating with a group of experts in wood modification to explore ways to match the performance of those proxies using timber that has been chemically and mechanically processed. With those new components, I will be able to design buildings that are self-cooling and naturally ventilated, entirely made of wood, to help reduce our global dependence on mechanical air conditioning. Thank you.